Hey guys, this is Coach Lowe, and we are looking at tests for parallelograms. This is contextual geometry 8.3. So you can go ahead and write this down in your notes. We're going to look at tests to see if a quadrilateral is a parallelogram. All right, so we put in your notebooks a green foldable that has different, we're going to put different things on it. And the first thing we put yesterday was a parallelogram. So we are going to continue with that and talk about tests for parallelograms. So we have a theorem, and this is theorem 8.7. And it says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if both pairs of opposite sides of a parallel or of a quadrilateral, so four-sided figure, are congruent, then the quadrilateral is a parallelogram. All right, so picture-wise, looks like this. There's quadrilateral ABCD, and AB would be congruent to CD, BC congruent to AD. So opposite sides, remember consecutive sides right next to each other. If I circle around this, they would be one right after the other. Opposite sides don't touch, so opposite sides here are congruent. Opposite sides here are congruent. So if I had to write that out, I would say segment BC is congruent to segment AD, and AB is congruent to CD. All right. So let me give you an example here. So this would be example number 1. It goes with this theorem. All right, so this is quadrilateral WX, Y, Z. And in quadrilateral WXYZ, triangle WYZ is congruent to triangle YWX. So W to Y to Z, this triangle, is congruent to triangle YWX, to the blue triangle. All right, so how could we prove that this is a parallelogram? Well, from our theorem, we would need to show that WX is congruent to ZY and that WZ is congruent to XY. So let's go over here and look at our letters because that's one way we can figure this out. So WX is in this triangle. So WX, it's marked twice, should be congruent to the two letters that are in the same spot. So remember when we did corresponding parts of congruent triangles are congruent, or when we were working with triangle congruency, once we write the triangles like this, it tells us what sides are congruent and what angles are congruent. So WY goes with WY, YZ with WX, and then WZ with YX. So we see that WX is congruent to YZ, which is what we wanted. Now what about the sides? WZ has to be congruent to YX. WZ, YX. And because they told us these were congruent, we know that these guys are congruent because corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. All right, so both pairs of opposite sides are congruent, therefore this is a parallelogram according to theorem 8.7. So as you do your problems in class, if you say yes or no, or if you say yes, you will have to list the parts that are congruent and then the theorem that we use, because I'm going to give you a couple more to be able to test quadrilaterals. So here comes the next one. Theorem 8.8. Theorem 8.8 says, if one pair of opposite sides of a quadrilateral is parallel and congruent, then the quadrilateral is a parallelogram. So no, when I write quad, it's quadrilateral. All right, so we want opposite sides of the quadrilateral if we know that they're parallel and equal in measure. Parallel to each other, so if they give us points, same slope, parallel to each other and congruent, then the quadrilateral is a parallelogram. Picture. So if I know these sides are parallel to each other and they also tell me that they are congruent, so AD is parallel to BC, but also I know that AD is congruent to BC, so maybe they are marked with 2 marks, then I know that my quadrilateral is a parallelogram. So one pair of opposite sides doesn't have to be both. One pair is parallel and equal in measure. So the equal in measure forces these two to be parallel to each other, doesn't it? Because they have to be same distance apart. These guys have to be same distance apart, which forces them to be parallel. All right, 8.9. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. All right, so what does that look like? So let's draw another parallelogram. So if the diagonals bisect each other, remember what bisect means? They're going to cut each other right in half, right? Which means E is the midpoint of AC. So different ways I could say this. E is the midpoint of AC. E is the midpoint of BD. So we would know that AE is congruent to EC and that DE is congruent to EB. All right, so the diagonals of a quadrilateral cut each other in half or bisect each other. So if they mark these two equal and these two equal, we know that this is a parallelogram. All right, so let's grab a couple of more examples and then we'll be finished. All right, so is this quadrilateral a parallelogram? And if it is, then how do you know? So you can pause the video, come back. All right, so now that you're back, yes, this is a parallelogram. Theorem 8.8 says if opposite sides are congruent and parallel, or parallel and congruent, then we're dealing with a parallelogram. Opposite sides are congruent and parallel, parallelogram. All right, let's try another one. All right, so this side's parallel to this one. This side is congruent to that one. All right, what do you guys think? No is the answer. It can't be theorem 8.8 because this side is not congruent to that one, and these two aren't parallel to each other. So it has to be both parallel and congruent. And then theorem 8.7 says both pairs have to be parallel to each other, and these two sides are not parallel to each other. So we have only one pair of congruent sides, or of parallel sides, and I'm sorry, congruent sides. I said parallel and wrote it. And so that's theorem 8.7. And also, it won't go with theorem 8 because these have to be congruent and parallel. All right, is this one a parallelogram? Oops. All right, is this a parallelogram? So remember what we're looking for. We want either both pairs of opposite sides of the quadrilateral are congruent. We want opposite sides are parallel and congruent, or the diagonals bisect each other. Diagonals bisect each other's out because I only have one diagonal. Opposite sides of the parallelogram are parallel and congruent. I don't have that. Both pairs of opposite sides are congruent. Well, I have one pair congruent. Let's see if we have congruent triangles here, because I see that they share a side, but this is side, side angle, and we know that doesn't work. Even though we have side, side angle for both, that's not going to work. Spells a bad word. And it would have to be side, 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 angle, angle, side, angle. One of the tests for congruency that actually hold all the time, and this is not one of those. So this is a no. It is not a parallelogram. All right, guys. So come back with questions if you have questions. Go ahead and write a M for math in the top right corner of the first page. An M for math in the top right corner of the first page. All right. Talk to you guys soon. This is Coach Lowe.